The first thing you need to do is factor the numerator and factor the denominator. So that means that our function is x squared minus 4x minus 5 is going to factor as x minus 5 times x plus 1. And x squared plus 3x plus 2 is going to be x plus 2, x plus 1. So you're looking for common factors, and in this case, x plus 1 is the common factor. That means we have a whole. So to find the whole, you set the common factor equal to 0. So we know that our whole, our x value, is negative 1. Now we need to find the y value. So you divide out the common factors, and you rewrite your simplified version, x minus 5 plus 2. So you take the x value that you just found and you plug it in to the simplified version, and that's y. So negative 1 minus 5 over negative 1 plus 2 gives you negative 6. So that means that our whole is at negative 1, negative 6. So usually I go ahead and graph that first thing before I forget. So negative 1, 1, 2, 3, 4, 5, 6. You just draw a circle around the point, and the whole was at negative 1, negative 6. Okay, the next thing I'm going to find is the x-intercept. So to find the x-intercept, you take the function and you set it equal to 0, and we can use the simplified version. So 0 equals x minus 5 over x plus 2. So basically you just need to find out where the numerator equals 0, so x equals 5. So our x-intercept is 5, 0. 1, 2, 3, 4, 5. And to find our y-intercept, you just plug in 0 for x. So 0 minus 5 over 0 plus 2. So y equals negative 5 halves. So our y-intercept is 0, negative 5 halves, which is 2.5. So there's that. So now let's do the vertical asymptote. So to find the vertical asymptote, you take your denominator and set it equal to 0. So here's our denominator, so I'm going to set that equal to 0. So x plus 2 equals 0, x equals negative 2. So that's our vertical asymptote. I'm going to go ahead and graph that. And for the horizontal asymptote, remember that we're looking at the exponents. So our function is basically x minus 5 over x plus 2. So you look at what the exponents are, and in this case, it's both x to the first. So since it's the same exponent on top and bottom, you look at the coefficients on x, 1 over 1. So in this case, the horizontal asymptote is the ratio of the coefficients, so 1 over 1, 1. So y equals 1 is our horizontal asymptote. I'm going to graph that. Now, the function can cross a horizontal asymptote, so I'm going to check and see if it crosses the horizontal asymptote. Well, in order for it to cross the horizontal asymptote, y would have to be equal to 1. So we set y equal to 1 and solve for x. Multiply both sides by the denominator. So since there's no value of x that will make this statement true, it does not cross the horizontal asymptote. So that's good to know. So now we're ready to graph. So we've got all these points down here in the bottom right, and we basically know that our function has to go through these points and then hug the asymptote. So it's going to look something like this over here. And then Our vertical asymptote is not a double asymptote. So because it's going down on the right-hand side of the asymptote, it has to be going the opposite direction on the left-hand side of the asymptote. So I know it's going to look something like that. Then for domain, you just need to think about what x is not allowed to be. So in this case, x is not allowed to be -2 or -1, but anything to the left of -2 is okay, so -infinity to -2. Anything in between -2 and -1 is okay, and anything to the right of -1 is okay.